Hey, I am Man Khatri. Welcome to our work titled Cite Case Law, Citation Worthiness Detection in Case Law for Legal Assistive Writing. What do we understand by citation worthiness? Given a sentence, we need to find out whether the given sentence is citation worthy, meaning that the sentence should have an external source to support itself in the given legal case. Lawyers and paralegals are required to cite related cases while drafting an ongoing case. With the development of AI recommendation systems, it is possible to do so, but it comes with the overhead for the recommendation system to find suitable citations for the given sentences. Our work tries to overcome this by selecting the sentences that could be the potential candidates for the recommender system, eventually reducing its burden by working on those sentences only. So, summing up the motivation. We aim for detection of upcoming possibility of citation without a database, which will eventually act as precursor to citation recommendation systems. There was also no available data related to the task of citation worthiness in this legal domain. In order to direct our research, we asked these three questions. How can we create a good dataset for the task? How various models perform on the task? How results are on legal benchmark after fine-tuning on our dataset? We have collected the data from Caselaw Access Projects, pre-processed it using regexes and sentence segmenters, labeled them using scripts. There are four categories under which we classify our sentence. For type 1, we can see that both of the sentences do not contain citation. So the first sentence will be marked as non-citation worthy. Type 2 is similar to the first, but the catch is that the second sentence has the citations but with a lot of text around, making it highly difficult to assign label to the first sentence. Such sentences are ignored. Type 3 sentences are also ignored. We discard the sentences with citations and information altogether present in one sentence. Modifying the sentence by removing the citations will not work due to grammar bias and will disrupt the sentence. In type 4, the second sentence has two parts, the word see and the following citation. We remove the second sentence and mark the first sentence as worthy as the second sentence indicates the first to be cited. Note that while creating the dataset, we mark a sentence worthy or not based on its following sentence. So as seen, our dataset will only contain these two type of sentences, that is type 1 and type 4. On the screen, you can see example sentences from cite and not cite categories from the cite case law. The bold green sentences were removed and the previous sentence was marked cite worthy or not cite worthy. This is how dataset was created. This table shows how we tried different models for the classification of sentences into citation worthy and not citation worthy. We tried from simple models to transformer models. As we can see in table, the domain-specific models had outperformed all the other models. We then took the best performing models and applied PU learning on that. Given the brief about legal BERT, it is a domain-specific BERT model trained on European, UK legislations and US cases and contracts. This answers our second research question about how different models perform on our dataset. Now this table shows the comparison of legal bird benchmarks on unfair toss and Ledger datasets and shows that training on our data keeps the performance on the older task intact. We have taken legal bird as the base model, so we also need to check its performance on the established datasets and compare it after training on our dataset. The main motive of the benchmarking is to measure performance on other legal documents as well, like the contracts which are less citation intensive. These results ensure the model performance which we hypothesize that it won't get poor. This answers our last research question. For understanding our models more better, we use the input into gradient method, specifically the variant utilizing L2 normalization over neurons to derive a pre-embedding score. This explainable method is used because it exhibited the highest agreement with human reasoning. This way, we compared model errors and see how models trained in different styles give importance to what tokens while making a decision. In the diagram, we can observe that LegalBird plus PU has classified a sentence correctly. Still, LegalBird could not do so with clear indications of the model giving importance to tokens differently for the same sentence. Now, that's all for today. Thank you.